Welcome, everyone. Thank you for joining the Canada Green Space Protection Coalition this evening. We are so pleased to be able to host this information presentation for you. For those of you who joined us live, you'll know we had quite a technical difficulty at the start of our live presentation. And so we've had to change our format, and we're going to be recording our presentation, and it's going to require us to do a bit of change on the fly. So please bear with us. Since the recent testing work started on the Canada Golf Club lands, many have been overwhelmed. We have had a group of homeowners on Shaughnessy Crescent, most especially, who have suffered damage, not from blasting, but from vibration and some other manipulations of the land. Now with the rains, we have some flooding. Perhaps the greatest concern for so many of us is what we don't know. And that is why we at the KGPC wanted to respond with this presentation this evening. To that end, we want to thank Capacity Engineering for responding to one of our members, Peter Francham, and getting this ball rolling for us. Information is power. We believe you will feel more powerful after hearing from our guests this evening. And we want to thank Peter for making the connection and locating Reed Paxton at Capacity Engineering. Reed considered our request, and as a result, we are all here this evening. Let me get this off the ground and rolling with one last welcome, everyone. Next slide, please. This is our agenda for the evening. It is short, and with our technical difficulties has gotten a little shorter. We're going to have to create a workaround. But before I move to introducing the Capacity Engineering team, I will do a little housekeeping. Our meeting was intended to be live on Zoom tonight. Our goal with that was to afford the ability to have question and answer session. We do that because the live feed also affords us an easy way to record and distribute it broadly to our supporters and community. So when it comes to the question and answers, what I recommend you do is write your questions down as they come to you and send them off in an email to the KGPC after you see this recording. We will reach out to our friends at Capacity Engineering and get back to you with some answers. And of course, make those contacts. So don't forget, write your questions down, and we will address them after the recording is released. Next slide, please. Allow me to introduce Maurice Quinn, who co-founded CEL with his father and brother and is now the president and principal structural engineer. He specializes in forensics, existing structures, seismic design, seismic upgrade, building envelope repair, restoration, fenestration testing, repair and design, as well as practical dynamic problems from sound and vibration to blast and defensive design. With extensive design and investigation experience both in Canada and internationally, Maurice's expertise is widely in demand. From developers to lawyers, owners to major contractors, clients have come to value his frank and honest assessments and ability to provide practical solutions and work around challenges. We very much appreciate your support and coming to be with us tonight, Maurice. My next slide introduces to you Reed Paxton as a partner and structural engineer at Capacity Engineering. Reed specializes in residential design, maintenance, and repair of both contemporary and heritage structures. His expertise extends to forensic investigations, including structural and building envelope investigations for both residential and commercial buildings. Reed also conducts condition assessments to evaluate existing structures. Reed is a grad of Carleton University with a Bachelor of Engineering and in high distinction in 2021. Reed focuses on timber design, but is also proficient in steel, concrete, and masonry. His commitment to excellence and continuous learning ensures that every project meets the highest standards of safety, durability, and functionality. Thank you, Reed, for being here and connecting us to Capacity Engineering. And with that, I'm ready to turn the slide presentation over to capacity. So welcome.
Screen share is disabled on my end, Neil. Can you enable screen share? You'll have to edit it out.
I'll send him a text message.
No, it's enabled. We're good.
Okay.
Thank you for that welcome, Barbara. We're pleased to be here and try to help. So as the introduction explained, we're an engineering firm. We do a great deal of work in Ottawa, and this is right up our bailiwick. This is the type of thing that we like to help people with. We're going to be discussing the blast engineering aspects of what can be happening in your neighborhood and community. If you have questions, of course, as Barbara said, please put them into writing by sending an email in, and we'll get back to the team and let you know what we think. I'm going to skip a bit of the introduction we normally do, but I will highlight that personally, I worked as a blast hazard engineer for the federal government. I actually designed the test chamber that is used for full-scale sample sections of walls to be built, and that's still in use by the federal government. That's my design. And I've done a variety of different blast and overpressure related work, as well as being a seismic engineer in New Zealand and other high seismic zones. It is an area in which I'm quite well known, and I have a great deal of expertise. In addition to the seismic work, which really isn't directly applicable, the blast work itself is entirely what we need to be discussing in terms of vibration and, of course, construction site blast work, the net effect or possible effect on your homes. You can pause if you're curious, but a few publications I've done. I think it's important that we talk generally about what structural engineering is. Not many people understand it as a field, and I very much like Dr. A.R. Dyke's take on what structural engineering should be thought about as being. Fundamentally, we're talking about probabilities. We're talking about using math to estimate loads and estimate responses for estimated situations and estimate the overall outcome. If you can see where I'm going with this, we're nesting a bunch of probabilities, and as a result, professional opinion comes to play. It has to do with experience, and it also has to do with the practical realities of whether or not tools are well adjusted to the problem. More on that in a minute. The key things we're going to discuss: what blast waves actually do, overpressure and the cumulative effects, the limitations of what will most likely be presented to you as the standard to which the developer will be working, potentially the city holding them to said as well, what I see as some gaps in Ontario's regulations, and what your community group can do in order to protect yourselves. Ultimately, what's going to be happening, as we understand it, is development in your neighborhood. That's going to require some blasting. Ultimately, that also means that someone is going to be doing excavation using controlled blasting. Common claims come from developers that everything's going to be fine. Damage is impossible with these, frequencies and the type of exposure that your buildings are going to see. That's not very truthful, to be honest, in my professional opinion. The reality is that your existing homes will most likely face a real threat. That can be quantified, but is often not. And the standards do exist to do better. I'm going to advocate that you insist upon the DIN 4150, which is the European standard out of Germany. Now, I get this wrong all the time, but Deutsche Informatik. Anyway, it's the German standards group. What actually happens in a blast event? There are a multitude of different things, but it's ultimately a high energy reaction, and it can be idealized to a point source. Earthquakes happen over long spans of plate, even intra-tectonic plate action. Those occur as almost a buckling of a plate, and they tend to have a center, but the action is happening over a wide area. When you've got the plates moving next to each other or subducting, you have very large zones from which energy is coming out. So you have wide field effects. They come as a wave through the earth, and you have both a P and an S wave. You have a compression type and you have a sinusoidal, which induces a shear in the earth. It's probably going a little fast, but think about it like this. You have more than one form of energy coming at your building in an earthquake. And in wind, you have more than one magnitude and direction. The wind ebbs as it flows, it lists as it wanes, it has a net effect. These things are lateral loads, but they are not good analogies to blast. Blast has both an in-air component with a significant potential for a negative component, as well as in ground, particularly for construction blasting of bedrock. You're going to see waves coming at you in the form of compression pressure wave in the air, which will blast around the building and then pull negatively on the lee side. It will suck a little bit on the building. And as that's occurring, you're also going to see compression and sinusoidal waves coming through the soil to hit the building. It's the interaction of these that will cause actual effects on your buildings. Generally speaking, this is well understood. You're going to most likely see things like drywall pops and minor drywall cracking. That's very typical. Ultimately, the old methods try to simplify all of this and argue that it's really not very much of anything. Well, I'm here to tell you tonight that really the testing that was done in the 60s and 70s by the US Department of the Interior, and upon which all of this work that's commonly thrown around in North America is based, it's not very honest for our new buildings. Our timbers are softer. Our details are different. The drywall is lighter and differently manufactured. These homes are no longer well taken as analogous to what was tested in the 60s and 70s, and upon which the ultimate permanent ruling in 1983 coming out of the US, which has been widely adopted in most of North America. It's not fair. It's not a good, robust example. Now, we could do a whole bunch of work and do all sorts of estimates. I don't think that that's important. I don't think that that's actually what you need. I'm going to get to what I think to be a simple and realistic solution. I just want you to first understand that the fact that the other people or engineers may come to you and say, look, these standards were specifically developed for timber frame housing. You have timber frame housing. They've been adopted and used all over. They're the dominant standard. None of that matters. Set it aside. Your situation, which you face, the reality of your community and your homes, not some standard developed by the Americans decades ago and applied to buildings all over, almost irregardless of any changes. Regardless, what's the difference between regardless and irregardless? Regardless of any changes, that is simply not a fair and practical assessment to apply to your buildings. Let's talk more specifically about the waveform energetics. So what actually happens? Well, first, very close to the blast, you have brisance. This just doesn't apply. We're not going to discuss it in any detail here. But after that, everything at a distance from the blast is affected by the pressure built up, which is often referred to as overpressure, the pressure higher than ambient. And in the ground, you have two forms primarily of waves. P, or compression. The particles are moving close to one another and then pulling back apart, much like a spring. And we have a nice picture coming thanks to BC Open Text. They have a Creative Commons share alike attribute type graphic that I think is very good, as well as the S waves, the actual waves that you can see in very, very significant earthquakes. You often see the wave traveling through the ground. It physically is visible. You won't see those long, high amplitude in blast, but it's the same thing in the ground. And that interacting, those forces interacting with the structure are what cause damage. That's what causes a reaction. Here's the nice way of picturing these. If you had a slinky and you pulled it away from the wall and you pushed rapidly and pulled back and sent sort of a pulse, you'd see those compression waves. Exactly that happens within the ground. We model it as waves and we take mathematical models to try and represent this, but this is what's actually occurring. At the same time, you also have sinusoidal form. You have S, or shear form waves that also occur, as if you were to take a belt and go like this and send that energy through as a sinusoidal wave. Both are occurring at the same time. They travel at different speeds, but they are fundamentally both very important and occurring. Let's be quite clear that what happens at your home is not actually well represented by any of the models we can work on. We can go all the way to hydrocode and get extremely detailed, but there's something called damping. All the small differences, all the loose bits, all the connections, these all have to move relative to one another. It eats up energy. How much damping an individual home has is almost impossible to get exactly right without very sophisticated testing, which you don't need. The solution I'm going to talk to you about still addresses that. We're modeling all of this with regard to peak particle velocity. We're looking at how fast the velocity of those particles being moved around by the blast, and then ultimately interacting with your foundation, or the air with the overpressure coming and sweeping and interacting with your superstructure, what's above the foundation. These are the net effects that are actually going to affect change on your building, potentially damage. Let's hold on to one fact from this slide. When people come to you with these older standards, they're talking to you about things which were described and created for older homes in specific soils, in situations that don't apply to you. And in my professional opinion, also blasting technology that the industry has left behind. It is virtually certain that what was used in these is nothing more fancy than fertilizer blast, which was very common back in the 60s and 70s. The old construction site blast mix, and I'm not going to discuss it. I'm not in the business of advising people how to make explosives, but it's a very crude and simplistic mix made on site. No one uses this anymore. The newer technologies that are used give a different form of energy. They're much higher in brisance. They actually have a different speed to react. The blasts themselves, which are the source of the energy, which ultimately causes the problems, is no longer the same as the standards that were used. You see, it's not fair to be held to those standards, despite the fact that industry loves to talk about them again and again. Overpressure. This is where you have an air blast that pushes on the walls and windows and then sweeps past it, draws along the building, and then sucks on the backside. And it's the combined action of these arriving and shaking your building and hitting in the multiple different ways that all supercrests to cause problems. I don't want to scare you. It's very unlikely that there's anything of significance to occur. We're talking about making sure that you're protected from damage that might happen. I'm not saying you're going to be in danger. I'm not saying they're going to destroy the value of your home. Don't take it as hyperbole. It isn't. We're talking about what modest damages are likely, will then be easy to prove, and something you can have corrected and repaired. This history matters. How was this all developed? It was developed in the 60s and 70s. It was developed on research with old blasting technology on older homes with less precision of the engineering, less knowledge in the industry. And it all comes about to giving you a set of regulations. I'll hold these for a moment so people can pause and read them if they're interested. These ultimately come to the fact that we've moved on. And interestingly, I've taken these from the International Society of Explosive Engineers. Now, ISEE is fantastic. They're good people, but their interest is in making sure that a maximum amount of blasting is permitted. I would say that in our situation, we're kind of looking at the other side, the engineers who are likely to argue that the blasting should go ahead. And I will tell you up front, in my opinion, most of this blasting should go ahead. I am not opposed to blasting in communities. You might not like hearing that as a community group, but I'm simply going to be honest and upfront and tell you professionally and ethically, I think this blasting probably should happen. However, the way in which it happens and what happens prior to it happening ought to be considered and done such that you aren't in a vulnerable position. Now, The permanent rules ultimately became this set of regulations which are now applied, and you're most likely going to have people bandy this about. This is what they're going to say. We do it to the industry standard. Fine. Yeah, you're doing it to the industry standard. Okay. But the industry standard lacks a few little details, and it really does not represent true risk to your structure, in my professional opinion. So what are the limitations of what they did? Well, look, it's very outdated. I've been bandering on about that this whole chat. But it also was created specifically with the intent of maximizing the permission to blast. That's the reality. This report was created to say, of course we can blast. We can blast closer. We can blast more. We can blast bigger. It is meant to facilitate coal production during an energy crisis. it is a biased intent. And even though engineers work to application of physics and codes and regulations, they're very ethical and professional. We are human, and we are affected. We are affected by what the client wants. That's just a net reality. Everyone has a bias. And the bias of this report is go, boy, go. Get those blasts. It's a known industry tactic to use this to dismiss community concerns. It's coming. I predict it. I don't need a crystal ball. I have experience, and we've been through this before. It ignores issues that are of import to you. It really isn't quite right for what you've got going on. In my opinion, this is something Ontario should do better on and close the regulatory gap and require the DIN 4150. I can make wishes, but, I want to advocate preventative preparations. Everyone talks about the blasting people coming around. They surveyed my house. They surveyed my house. Fine. But the reality is that documentation, the information that they create, they will deny you. You will not be afforded an opportunity to look at those tapes or photographs. They will hold them, and upon complaint, they will audit against the data they have, and they'll simply say, pre-existing damage. You don't have a right to their working papers, to their information, to the data they collect. So even though our firm doesn't do surveys, and I'm telling you to go hire someone to do this, we could tool up if you really trusted us and wanted to do it. We've got the stuff, we just don't. But get your own surveys. Know what your conditions are. Because the reality is, if you have a blasting occur and you have a vibration in your home, you may see things that were legitimately there before the blast. That's absolutely possible. And you think they're new, but they're not. It is not frequent that people really understand the state of their home. That's quite rare. And ultimately, the reality is, with proof and documentation, you don't need to argue. You simply say, look, that's the condition before. Here's the condition now. What happened in between was you. So you just need access to this information. And it's not that I'm saying that they would be dishonest with what the surveys say, but you would have access to all of it if you commissioned it yourselves. And by having that information on hand, it simplifies all of this greatly. I want to talk basically about the fact that, you're most likely going to have a hard time limiting someone to use or develop their land. You need to be reasonable in what you ask for. You need to be asking for preventative cautionary steps, the application of reasonable technologies and the best available reports and testing and standards. And you need to be in a position where you can actively pursue that your interests form the path of least resistance for the bureaucrats involved. You want the city and the developer and other people to see that it is in their best interest to do something of a compromise that meets with the community's satisfaction. That's my professional advice. It's the closest I'll come to a lawyer for you tonight. And I similarly advise clients in complicated situations, is there something else that would benefit your community? If they're going to do the blasting anyway, get involved, make sure they're going to do it in a way that is maximally protective of your community, minimizes danger on your structures, and prepare yourselves to prove what the case would be, And maybe there's some horse trading here. Maybe your community gets a pool out of this. I don't know. I simply say pick a line that works. Don't insist on perfection. The enemy of good enough is not your friend. I'm happy to take questions. I don't expect a great deal of them immediately, but we will happily accept questions over the coming days and work with the group to make sure that you get those answers. I do want to highlight that it really comes down to knowledge being the weapon of choice here. And you need to be quite careful about documenting and having a good chain of custody on all that information, and ask for something reasonable and practical as a solution for your community. Thank you so much for your time and attention.
So thank you very much, Maurice, for the presentation. Because we were not taking question and answers live through YouTube tonight as a result of our technical problems, our approach is going to be a distribution of our recording. And we'll track that over the next week or so, and encourage everyone to email your questions coming from the presentation to us at info@ourcanadagreenspace.ca. And we have an e-news coming out the end of the week, and I'll reproduce that address in there for you. And what Maurice and Neil have kindly Maurice and Reed have kindly agreed to do is to rejoin us in another call. We'll have our fingers crossed. Hopefully we won't have the technical glitches, but what we'll do in that call is specifically address your questions and any other topics that you might like a few of their thoughts on. And we'll hopefully have that be back out to you with that opportunity within a few weeks at the outset. So thank you again. Heartfelt apologies for the technical glitches this evening. But we do hope you found Maurice's presentation as informative as we did. Have a good evening, and thank you again.